All right. The point of this particular lecture is to just kind of combine some of the things I've already discussed and to point out a couple terms that I may have missed or skipped that are important, and it's something that we kind of need some extra explanation of at this point. So it's not about reptilian classification. This is more about the specifics of cladograms versus phylogenetic trees and some of the terminology. Later in the course, we'll go over reptiles more, and then some of those details will actually be important. Right now, I'm going to talk about some terms related to reptiles and vertebrates, but those are not the important terms. It's more the terms about the branching structures we're talking about here. So that's kind of setting the picture of what we're looking at. Over here, we have a cladogram. And here we have a phylogenetic tree. And they pretty much have the same information in them, or the same groups, but you can see that they're slightly different. Okay, so over here, we're going to start with the cladogram first. Right. This is a cladogram that's looking at a number of different vertebrates, but not all vertebrates. What we're doing here is we have ancestral characteristics or traits. So check this pen here. Okay. So the ancestral characteristics or traits have a term that you might see or read about called Plesomorphies. All right. So these are Plesomorphies are the ancestral traits, and those are traits that everyone in this cladogram should have, right? So they have to have a common ancestor. In this particular one, these are all vertebrates. But that's not it, because there are other groups of vertebrates that aren't included here, like fishes, for example. And amphibians, are not in this particular cladogram over here. I do have amphibians over here in the phylogenetic tree. What else do we have? Well, in addition to being vertebrates, these are all tetrapods. Tetrapods mean they have 4 limbs. That would rule out the fish, so there's no fish in here, but still amphibians could be in there. And then another characteristic here, they're amniotes. So all the members of this particular cladogram that we're looking at have an amniotic egg as well. So there's the birds, group that we refer to as the reptiles, which you'll see is a little messed up, all right, and the mammals over here as well. So what we're doing as we build a cladogram, we have our nodes, okay, our branching points. And each of these branching points have a characteristic or trait, and at that point we are deciding either yes or no, they have that characteristic trait, or they don't have that trait. So the characteristic trait we used here in this particular one is aglandular, no glands, skin. So mammals have a whole variety of glands. We do in our skins, all these sebaceous glands, and these guys don't have those. So that separates the mammals out. Into their own separate group, and we're just going to kind of leave them there for right now. Now we have all these others. So there's testudines, the turtles, different types of lizards, tuataras, the lizard groups, which are also can be broken into smaller groups. We're not doing that here. Snakes, crocodilians, and birds. That's what we have. So now we're going to further separate them out. And the way, again, this particular cladogram is doing that is it's going to be looking at skull features. All right, so certain characteristics of a skull. So generally, there are some things that we'll talk about specifically, and you will have to know these terms later in the course when we talk about vertebrates and vertebrate skull structures. Right. Now we're not. You don't have to know these, but I'm going to bring them up because that's part of how this cladogram is built. So these are terms that are referring to vertebrate skull types, anapsid, diapsid, and synapsid. And what they're referring to are holes, essentially, in the skull. So I'm going to do this. This is supposed to be a skull. That's the top part over here, not the lower part, not the mandible over here. And if we look at them, the turtles, right, are anapsids, which means that their skull looks like this. So they have an orbital opening for the eye, they have a nasal opening, and then there are no other openings, right, in the skull. And so that brings them out as their own separate group. So what is it, though, that the characteristic that all of these share, all of these here have that the turtles don't? Well, they are all going to be of the diapsid type and have so these are all going to be diapsids. And going to have these two openings in the skull. And so these openings are a supratemporal opening up here. And then so that's an opening here. And then there's another one that's sort of behind the orbital over here. And this is something called infratemporal. So our diapsid skull has these holes in it. And so and there also have the holes are called fenestrae. And so the anapsid turtle skulls don't have them, but the rest of these do. So now we're going to separate them further, okay, into another group. Well, what we have is that crocodilians and birds have additional openings that these don't, right? So they have these antorbital just orbital openings, and in addition to that, there's an additional opening in the jaw, which is for musculature and all. So they have these additional openings. So we'll put the antorbital one. And these don't have it, and so that puts them into a grouping. We're going to further divide up the birds and crocodilians. We'll say here, we could do something more simple, like feathers, or the toothless beak. Something to that effect. Although we have, bird ancestors have teeth in jaws and so on, but we're kind of going along this line. You can also see this group here with the snakes, lizards, so the squamata, tuataras, another lizard-like group, but they're different. They have their own unique characteristics and traits. You can see here. They get branched off. Now, what's the whole point of me talking about all this detail of lizards when we said we're not talking, and reptiles and mammals, birds, and so forth? When we said we're not talking about that right now, that's not part of our terminology. It's really about the cladogram. So what kind of terms do I want to really bring out that I think you need to know? Well, the first off is this. This group here, right? That's the group that we call reptilia. And you should be able to see, by looking at a cladogram, there's a problem, right? We're including the crocodilians in with these others, right? So we could include the tuataras, the lizards and snakes together, definitely the lizards and snakes together. We could potentially drop back and then even use the other skull type. This is a totally different skull type, right? But we could include the turtles, and that would still be okay. But if we include the crocodilians, then we really have to include the birds. And if we don't include the birds, then we shouldn't include the crocodilians. So crocodiles shouldn't be reptiles, or birds should be reptiles. So it gets kind of confusing. It's like, so what's going on? Well, there's a term for that. We refer to this reptilia as being what we call paraphyletic. My markers are getting a little old. I'll have to get some new ones. So paraphyletic. So that means that if it's paraphyletic, we are not including, so we're either including members of a separate group in with the group, or we are excluding members that should belong to the group, but we're not including them, or keeping them out. So the group that we're talking about is either missing members or it has extra members in it that maybe shouldn't be there, and that's what we call it. Now, that is opposed to a different term, the term monophyletic. We want all of our groupings or classifications of living things to be monophyletic. We hope that they are, because what monophyletic means is that they all share a common ancestor, and it's important, all members are included. Members based on the cladogram, that you drew. And so the cladogram is based on characteristics that were chosen in this particular one. Many of them are morphological features, physical characteristics. So here's the thing. You can then make a cladogram and choose a particular set of features and then find that there are problems or issues with it. And so then you can then make another cladogram and use different characteristics or features. You may end up finding the same thing. You may end up finding something a little bit different. So the idea here is that you can make multiple cladograms. The cladograms have to have very specific characteristics or traits. All right. One cladogram shouldn't mix different types of traits, meaning if this is a skull type, the next feature should not be molecular gene sequence. You can make a new cladogram based on gene sequencing for these same organisms and then come up with the same or similar type of branching diagram. And that will tell us either, oh, this is these are good characteristics and they support each other, or there's some confusion here because now the cladogram turns out very different. And ideally, what you're trying to do to find out the relationships of living things are create multiple cladograms for the same groups using different types of characteristics or features. So physiological characteristics, morphological characteristics, molecular characteristics. And then you're kind of overlaying them with one another. Things that tend to fall out always the same, hold on to. Things that tend to be different between them, then other things will come into play to determine which ones you will choose to consider more so than others as being important to the classification of the organisms. This doesn't really represent anything to do with time. So there's no time involved here. It's not like this happens. I mean, generally, if these are closer together, probably they were more related, yet they could have branched away from one another a very long time ago. It could have been almost at the exact same time, this other branch happened. So all these branches could have happened all around the same time, but that's not what the cladogram is showing. The cladogram is just looking at characteristics and traits, and the main thing I want you to take away from it is that a single group. So for example, I should give you an example of this because I haven't done it yet. Lizards and snakes, if we just consider them, they are a monophyletic group. Both members are there and they share a common ancestor. And nobody else should be in that group necessarily, and that's good. Okay. If we try to include crocodiles with lizards and snakes, they both share different ancestors as the most recent common ancestor, and there'd be someone left out. The birds would be left out, here. In addition, from that common ancestor too, you have this guy over here. All right, so and he'd be left out. So if you went back to this point, you'd be leaving out these guys here. Those would be then paraphyletic groupings, meaning that we're missing someone, or or we're adding in extras that maybe shouldn't be in the group. That's the idea. So know those terms. Monophyletic, a group that shares a common ancestor and that all members are present. No one's excluded. Versus paraphyletic, which is either a group that's missing members, they should be there, but for some reason we chose to just not include them, like the birds, right? Or they include extra members that maybe we shouldn't have included, like the crocodiles, again with the reptiles. That's the sort of idea. Coming down here to look at the phylogenetic tree. With the phylogenetic tree, this is going to, keep in mind, look a little bit different. So generally when you see this more of this Y-typed branching diagram is usually where we're talking about the cladogram. When you see phylogenetic trees, they can look kind of different. So people often will do this kind of boxed sort of look to it. Sometimes it actually be not straight lines, but actually kind of curved lines. You'll see that as well. The phylogenetic tree includes a whole variety of information. All right. So as much information as we can consider. So we'll just say, really, it should contain all information available. Meaning we're considering the, say, molecular gene sequence cladogram. We're considering this particular physical trait cladogram based on skull type. We're considering all kinds of other information. In addition, this phylogenetic tree is also going to consider time. So evolutionary time through the geological record. So that's also what's going to be included in terms of branching, where we see certain groups appear at certain points in time closer to other groups. We'll tend to then put them closer in the actual phylogenetic tree. That's not the case. Cladograms don't represent time. The length of these do not represent time at all. But here, this is not direct, but sometimes the length and time, they don't equal one another, but it's an approximation of time. So longer branches are separating the organisms by more time. That means they separated from one another longer ago. And that is part of the depiction seen in the drawings of the phylogenetic tree. So phylogenetic trees take into account time, plus a variety of other characteristics. The cladograms do not take in consideration time. The cladograms only have these specific features, and when we get groupings from them, we're using this terminology like monophyletic, paraphyletic. There's also polyphyletic, which is where you might have actually very different ancestors. Maybe a totally different cladogram over here, but yet we try to include organisms from this cladogram and a different cladogram as being one group, but they would actually not even share a more recent common ancestor, so they would be polyphyletic, many different ancestors is kind of with that group. So not really a particularly good group to have or call out, like the protistas we'll talk about. Some of them, the way we discuss them, are technically polyphyletic based on other information. But we just to classically discuss them, we might talk about them together. So that's the case with the reptiles. Classically, they are discussed together as a particular group, even though we see they violate some of these rules that we're starting to learn about how we classify organisms. They don't meet them. They break the rules. But we still kind of keep birds as their own separate class and reptiles as a class, and we include the crocodiles with the reptiles. And that's sort of a traditional way that it's done. So I think I covered these basic terms. So that's kind of, I think I talked about some things that were already discussed in other previous lectures, but I wanted to kind of put this together because I saw in some of the quizzes a few of the terms were lacking, or there might not have been a good link or connection between some of these two different topics, or a direct comparison between them. So hopefully you can kind of see that here. Usually you get the same sort of layout with the phylogenetic tree. We also have down here amphibians, here, then the mammals are pulled out. Then you have kind of these groups here, which again should represent what we classically call reptiles. The turtles are pulled out first for their different sort of skull type. And then we have the lizards, which also snakes would be in this group. This is a more simplified version. Then the crocodiles and birds. But still, once again, the crocodilians and the birds are closest together, closer than these other groups to one another. So really they form a group on their own, but it's just not something that we currently have a name for or recognize. Now, there are, but that's nothing that we're going to use in the class. So hopefully that clears up some of the terminology a little bit more, and then it also gives you a little bit of a look forward as we get into future studying of vertebrates, some of the characteristics and things that we'll use to separate them. So we'll be coming back to some of this later.